Hiya, this is Andrew, and today we are gonna go over AASL Booster Paper C1. The booster papers are supposed to be easier than my mocks, therefore that will be great preparation for the real exam. First, we are asked to find the mean of a sample. To find the mean, you just need to find the sum of all of the numbers, then divide by the number of numbers. We have 8 data points here, and you should get 15 as your final answer. The standard deviation. You're not expected to calculate the standard deviation without technology, but if you do, you will get square root of 21 as your answer. In part B, you're asked to indicate what would happen if each of the data points is increased by 3. If each data point is increased by 3, the new mean would increase by 3 units as well. The standard deviation will have no difference because the standard deviation measures how different you are from the mean. If all the data increased and the mean also increased by the same amount, then the standard deviation remains the same. So it is still square root of 21. Question 2 is on quadratic functions. And in part A, you're asked to complete the square. To do this, the first thing, we're going to factorize the 2 from f of x. That would leave us with x squared minus 4x plus 5 divided by 2. Second step, now we need to express this as a perfect squared plus a constant. X squared is essentially 1x squared. We now need to split the middle term into 2 times 1x times another term. This term has to be negative 2. To make it a perfect squared, we'll then have to add this quantity squared. So this part over here would give you a perfect squared. But because you just add this, you also have to subtract it to make it back to normal. And then of course you would carry the 5 by 2 down. The first 3 terms is effectively x minus 2 squared. The constant term, we still have 5 by 2 minus 4. So if we expand everything, we will get 2 times x minus 2 squared minus 3 as your final answer. Part B. First, you're asked to write down the coordinates of the vertex of the parabola. So, recall that the vertex of this parabola is at hk. In this case, h is equal to 2 and k is equal to negative 3. Two, write down the minimum value of f. So the minimum of f is negative 3 because 2 times x minus 2 squared is greater or equal to 0. Therefore, f of x has to be greater or equal to negative 3. In other words, your k value. In question 3, you are given a cubic function, and first you're asked to differentiate f. This is pretty straightforward. And now we can simplify our expression. To find the intervals on which f of x is increasing, we will set f prime of x greater than 0. This means this has to be true. We will now need to factorize this quadratic on the left-hand side. We can split the negative 5 into negative 3 and negative 2. This is a quadratic expression on the left. To solve this inequality, the easiest way is to make a sketch. The roots are at 2 by 3 and 1. Because the coefficient of x squared is 3 greater than 0, the parabola is opening up. So your parabola will look something like this. This root over here is 2 by 3, this root over here is 1. This is obviously not to scale. We are only interested in the intervals on which it is positive. Therefore, we will look at the parts that are above the x-axis. In other words, x is less than 2 by 3, or x is greater than 1. In part C, you are now asked to find the values of x. In part C, you are asked to find the values of x where f is concave down and increasing. The moment you hear the word concavity or concave up / concave down, this means you will need to find the second derivative. So f prime is 6x squared minus 10x plus 4. The second derivative is therefore 12x minus 10. It is concave down. This means the second derivative has to be less than 0. This means that x has to be less than 5 by 6. However, we also need to find the values where it is increasing, which is just found up here. Therefore, the only intervals that satisfy both requirements is x less than 2 by 3. If it is still unclear, you can draw a number line. First inequality allows us to take this part. The second inequality allows us to take either the part on the left or the part on the right. We're interested in the parts that are common to both inequalities. Therefore, we are only interested in this portion over here. In other words, x is less than 2 by 3. This question part is on probability. You're asked to find the conditional probability P of A prime given B. So first, it is always a good idea, and it will guarantee a mark, if you attempt to express this in a more useful form. So using the definition of conditional probability, this is equal to probability of A prime intersecting B divided by the probability of B. You may also find it useful to represent this on a Venn diagram. We know that the probability of A intersecting B is 1 by 5. We know the probability of A is 3 by 5. And we know the probability of A union B is 3 by 4. So based on the diagram, we can already fill out all the probabilities. This probability over here has to be 2 by 5, because those two add up to 3 by 5. This probability over here has to be 3 by 4 minus 1 by 5 minus 2 by 5, right? Because all three of them add up to 3 by 4. This means that this probability over here is 3 by 20. And what's left is this portion over here, which is a quarter, or 1 minus 3/4. probability of not A intersecting B. Where is not A intersecting B? It's this portion over here, right? That is outside of A, but inside of B. This part is 3 by 20. The probability of B is gonna be this portion over here. That includes the 1 by 5 and the 3 by 20. So we can now add the two fractions in the denominator, and that will give us 3 by 7. That is the end of this question. This is a rather atypical question. Question 5. You are given triangle ABC, you are given the lengths, and you are given angle BAC is 2 theta, and you're asked to find the exact value of cosine of theta. Right off the bat, you can see that this is setting you up to use the double angle formula because you have 2 theta over here. Besides, you have 3 lengths. So the only rational move is to find an expression for cos of 2 theta. BC squared is equal to AB squared plus AC squared minus 2 times AB times AC times cos of 2 theta. BC squared, AB squared, AC squared, AB, AC, cos of 2 theta. 64 is equal to 65 minus 56 cos of 2 theta. So 56 cos of 2 theta is equal to 1, and cos of 2 theta is 1 by 56. Cos of 2 theta is 2 cos squared of theta minus 1. This is one of the identities that you must know. Cos of theta is gonna be 57 by 112. Sorry, cos squared. And therefore, cos of theta is gonna be the square root of this number. We know that the square root must be positive because 2 theta is less than 180 degrees, the sum of the angles in a triangle. Therefore, theta is in the first quadrant. And therefore, cos of theta must be positive. Question 6 is another question that is very likely to show up on your exam. It may look very intimidating, but it's really not too bad if we take it one step at a time. So first, looking at this integral, the first thing we should do is integrating this. The integral of 2e to the 2x is 2e to the 2x divided by 2. This 2 over here is effectively the derivative of 2x, so you are doing the chain rule in reverse. Similarly, for the second term, that will be 5 by 2 e to the negative 2x divided by negative 2. The upper and lower bounds are m and 0 respectively. We are now going to substitute the bounds into our integral. That's the upper bound minus the value of the integral at x equals 0. That would be 9 by 4. Therefore, e to 2m plus 5 by 4 e to negative 2m minus 3 is equal to 0. Now we can multiply the entire equation by 4. Notice that this is a quadratic equation in disguise. If it is not clear, you can use a substitution. Let's say t equals to 2e to 2m. your equation becomes 4t plus 5 divided by t minus 12 is equal to 0. Multiplying everything by t, factorizing the resulting quadratic, and your t is either 5 by 2 or 1 by 2. Therefore, e to the 2m is equal to 5 by 2, or e to the 2m is equal to 1 by 2. However, pay very close attention to this. M is a positive constant. You're given this in the question. Because m is a positive constant, this means that e to the 2m has to be greater than e to the 0 or equal to 1. So this guy doesn't have any solution. If it is still a bit unclear to you, I would always recommend sketching out the function. This part is 1, the y-intercept. 1 by 2 is somewhere over here, and your value of m must be negative. Therefore, the only value of m for this to work is when this is true. Take a ln of both sides. That will give us the value of m. Question 7 is on normal distribution. For all normal distribution questions, I highly recommend sketching out the distribution to remind yourselves of the possibility of symmetry. The mean of a distribution is at 0. We know that our probability that x is greater than 5 is equal to a, and the probability that x is less than negative 12 is b. Because of the symmetry of a normal distribution, we know that p of x greater than 5 is equal to p of x less than negative 5. And this entire area is also equal to a. From the sketch, we know that p of x less than negative 12 must be less than p of x less than negative 5. Therefore, b is less than a. In part B, 1. You're asked to find the probability that x falls between negative 12 and negative 5. We know that this tiny part here is b. We know that this bigger part here is a. From negative 12 to negative 5, this is this tiny part over here. So just by looking at it, we can already write down our probability. This is equal to a minus b. In part 2, this is a conditional probability. This probability is equal to p of x less than negative 5 intersecting negative 12 less than x less than 12 divided by the probability of negative 12 less than x less than 12. How do we simplify this intersection over here? We need to find all the values of x that are less than negative 5, but also has to be between negative 12 and 12. This means that the part that we are truly interested in is this tiny portion in between. So this can be simplified to p of negative 12 less than x less than negative 5. This is also why we have part B1. So usually if a question asks you to calculate a quantity in the previous question part, most likely you are going to use it somewhere in the question. This probability is a minus b, as seen above. P of negative 12 less than x less than 12. We'll use the same principle here. The probability of x less than negative 12 is equal to the probability of x greater than 12 by symmetry. This part over here, that's b. So, if I am to sketch out this entire distribution, we know that from here to here, that's b. From here to here, that's b. The sum of the entire segment is 1. We're interested in the part right in between. Therefore, this probability is going to be 1 minus 2b. And this is the end of b2. In this part of the question, you're asked to consider a different distribution of mean 10 and variance 4 sigma squared. In other words, the new standard deviation is 2 sigma. You're also given that p of m less than y less than n is equal to 1 minus a minus b, as seen above. First off, this is very intimidating, and this part is definitely not easy. So, on the real exam, if you're stuck on this part of the question, please move on. It's not worth it. However, if you do choose to attempt the question part, remind yourselves of the distribution from part A. This is A, this is B. The 1 minus A minus B would be this part over here, right? This part is A, that part is B. The entire thing is 1. So it can be this region. So P of m less than y less than n is equal to P of negative 12 less than x less than 5. But that's only one possibility. Another possibility is when this curve reflects about this axis over here. So negative 5 to 12 is also another feasible option. Why is that the case? Because the probability that x is less than negative 5 is A. The probability that x is greater than 12 is B. And what's left is once again 1 minus A minus B. So those are the two options. Now let's go back to our question. We know that P of m less than y less than n is equal to P of negative 12 less than x less than 5. This is going to be our first option. This means that when we normalize, they should have the same set score. So let's normalize this. Normalizing m, we will get m minus 10 divided by 2 sigma. Less than z less than n minus 10 divided by 2 sigma. On the other hand, we'll have negative 12 minus 0 divided by sigma, and 5 minus 10, 5 minus 0 divided by sigma. 0 is the mean of x. This guy is the mean of y, just to remind you. Therefore, n minus 10 divided by 2 sigma is equal to negative 12 divided by sigma, and n minus 10 divided by 2 sigma is equal to 5 divided by sigma. In other words, n minus 10 is equal to negative 24, and n minus 10 is equal to 10. So m is negative 14 and n is 20. This is the first possible scenario, which is also part C1. C2 asks for the other possibility. So we'll do the normalization process again. But this time, x is between negative 5 and 12. Normalizing this, we'll get n minus 10 divided by 2 sigma is equal to negative 5 divided by sigma, and n minus 10 divided by 2 sigma is equal to 12 divided by sigma. Now we just need to solve for m and n. M is therefore 0 and n is 34. So those are your two possibilities. This is the end of question 7. Question 8 is on logarithmic function. And in part A, you are asked to evaluate f of 8 root 8. So replace x with 8 root 8 and we shall see where we can go from here. We would like to express the entire argument in base 8. 4 is 8 to the 2/3. The cube root of 8 is 2. Square it and you get 4. So 4 is 8 to the 2/3 times 8. Square root of 8, that is 8 to the 1/2. That will give you log base 8 of 8 to the 13 by 6. Therefore, it is equal to 13 over 6. In part B, you are asked to find an expression for the inverse of f. So let's start off by writing out f again. To find the inverse, first you need to find x in terms of y. So 4x is equal to 8 to the y using definition of logarithms. Therefore, x is 1 by 4 times 8 to the y. Now we're going to swap the variables. And we replace y with the inverse of f. And that is all you have to do. In part C, you're given g of x is log base 2 of 2x minus 4. And you're asked to express it in base 8. So, how do we do this? Let's change the base first. Log base 8 of 2 is 1 by 3. So we are now halfway there. Also notice that the argument is in the form x minus 2. That means that we need to factor the 2 out of the current argument. Using laws of logarithms once again. And this will simplify to 1 plus 1 plus 3 log base 8. This would simplify to 1 plus 3 log base 8 of x minus 2. Moving on to the second part. You are now asked to move from log base 8 of 4x to 1 plus 3 log base 8 of x minus 2. So, how do we do that? We are going to start with the horizontal translation of 2 units to the right. Our curve now becomes log base 8 of 4 times x minus 2. So we get this part down. Now we are going to use log laws to see what we have to do next. Okay, we are missing that factor 3. So the next transformation is a vertical enlargement with scale factor 3. This now brings us to 3 log base 8 of 4 plus 3 log base 8 of x minus 2. This guy is 2. Lastly, now we'll match the constant term. And we all know that we will have to translate this curve 1 unit down. This is one way to do it. Make sure that the translation down occurs after the vertical enlargement. Otherwise, your transformation will not be the same. And this is the end of question 8. This is question 9, the last question of the paper. We'll start off with a relatively straightforward trigonometric equation. To solve this, we need to isolate for cos of x. Now we want to solve two equations. Cos of x equals to root 3 by 2 and cos of x equals to negative root 3 by 2. I highly recommend sketching out the unit circle. If you're more comfortable dealing with functions, then alternatively, you can also sketch out the curve y equals to cos of x to help you solve the equations. Cos of x equal to root 3 by 2. This is true at the intersections of line cos x equals root 3 by 2 with the unit circle. X is either equal to arc cos of root 3 by 2 or 2 pi minus arc cos of root 3 by 2. In other words, pi by 6 or 11 pi by 6. If you would like to use the function, then you can just draw the line y equals to root 3 by 2. And that will really help you to determine the right intervals to look at. Similarly, if cos of x is equal to negative root 3 by 2, x is equal to arc cos of negative root 3 by 2, or 5 pi by 6. I'm going to use green for this. So this is the line cos of x equals to negative root 3 by 2. And these are the two angles that you're looking for. The first angle is 5 pi by 6. The second angle is 7 pi by 6. If you want to use the curve, you can also draw the line y equals negative root 3 by 2, and then find the intersections. Moving on to part B. In part B, you're given the graph of f. B1. Show that cos of x minus 2 less than 0 is true for all real values of x. This is trivial. We know that negative 1 is less than or equal to cos of x less than or equal to 1 for all real x. It is always between negative 1 and 1. Therefore, minus 3 is less than or equal to cos x minus 2 less than or equal to negative 1 for all real x. And this is less than 0. Therefore, we have just proved the inequality. Now we want to solve the inequality f of x greater than 0. This is true if cos of x minus 2 times 4 cos squared minus 3 is positive. This part we just proved to be negative. The product of a positive number and a negative number is negative. For it to be positive, this quantity over here also has to be negative, because the product of two negative numbers is negative. Therefore, for this to be true, 4 cos squared minus 3 has to be less than 0, or cos squared of x is less than 3 by 4, or cos of x is between root 3 by 2, it's between negative root 3 by 2 and root 3 by 2. Going back to the curve. This means that our values of x are in this part over here and that part over there. If you're using the unit circle, it is between these two values and those two values. We have found from part A that this point over here is pi by 6, this point is 5 pi by 6, this point is 7 pi by 6, and that point is 11 pi by 6. So our solution set is from pi by 6 to 5 pi by 6 exclusively, or 7 pi by 6 to 11 pi by 6 exclusively, endpoints excluded. Part C. We now want to find the integral of f of x dx. This is the integral of cos x minus 2, 4 cos squared minus 3. First, we'll expand the brackets. 4 cosine cube, 8 cosine squared, minus 3 cosine, plus 6. Cos cube. This is the hardest term to integrate. To do this, you're going to split the cube into 4 cos of x times cos squared of x. The reason is that we are going to use a substitution here. For the second term, cos squared of x, this is begging for a double angle formula. Notably, cos of 2x is equal to 2 cos squared of x minus 1. So cos squared of x is going to be cos of 2x plus 1 divided by 2. Do not forget your brackets. 3 cos of x, we cannot do anything with it. Plus 6, we also cannot do anything with it. We can now express cos squared in terms of sine squared for us to use a substitution. 4 cos of 2x over here, minus 4 plus 6, that will give us plus 2. Now we are ready to integrate. If u is equal to sine of x, du is going to be cos of x. So this part becomes the integral of 4 1 minus u squared du. For the remaining terms, we can also integrate it immediately. First bracket, the first integral will give you 4u minus 4u cubed divided by 3. The second integral, minus 4 cos of 2x, that would give you negative 4 sine of 2x divided by 2. Do not forget the reverse chain rule. You can use a substitution for this, but after doing enough practice, this will come naturally to you. Integral of 2, 2x. Integral of cos of x, sine of x. Do not forget your plus c. And now I'm going to substitute the u with sine of x. Minus 2 sine of 2x plus 2x minus 3 sine x plus c. Therefore, we will get the printed answer. The last part of the question asked you to use this result to find the area. When finding the area, you must use the absolute value sign or the modulus sign, because area cannot be negative. So the area is going to be the integral from 0 to 2 pi of the absolute value of f of x. We know that the curve is symmetrical about x equals to pi. I'm going to quickly sketch out this function again so we have a better idea of what I mean by this. We go up, that's going to go down, that's going to go up, that's going to go down. Because it is symmetrical, that means that this area of the regions to the left of this line is equal to the area of the regions to the right of this line between pi and 2 pi. So this is 2 times the integral from 0 to pi of the absolute value of f of x dx. Now we have to be very careful. This part over here, below the x-axis. This part over here, below the x-axis. Therefore, when you break out of the absolute value sign, it will be negative. So, we'll break it up into 3 parts. First part, second part, third part. It is a good idea to evaluate each part separately, because it can get very complicated very quick. So be organized. I1 is the integral from 0 to pi by 6 of fx dx. This means that we are going to take the result we just obtained from the previous part and plug in the upper and the lower bounds. If you did not get this result, please take the printed answer. It is there for a reason. If you still stubbornly use your own wrong answer, you will not get any accuracy mark. Now let's plug in the upper bound. Sine of pi by 6, that is 1 by 2. Sine of pi by 3, that is root 3 by 2. Sine of pi by 6, that's 1 by 2. 2x, that's pi by 3. Sine of 0, sine of 0, sine of 0, sine of 0. You don't even have to include this. That's the first part. Second part, I2. I2 is an integral from pi by 6 to 5 pi by 6. So we are going to do the exact same thing. Except at this point, you have to be very careful. I'm going to do it one step at a time. First, I am going to substitute the upper bounds and the lower bounds into our expression. The lower bound is actually this part that was just found for the previous part. So if you are a little sneaky, you can literally use it to simplify your computations. Okay, sine of 5 pi by 6. Sine of 5 pi by 6 is the same thing as sine of pi by 6. So 1 over 2. Sine of 5 pi by 3. Now this is tricky. 5 pi by 3 is somewhere over here. So this guy is gonna be negative root 3 by 2. Same thing. Same thing. I'm gonna distribute the minus sign. The last integral is from 5 pi by 6 to pi. Let's plug in the upper bound. The lower bound here is gonna be this portion. Or you can of course reevaluate this. That's totally up to you. Sine of pi is 0. Sine of 2 pi is 0. So this is simply 2 pi. 1 by 3, root 3, 5 pi by 3. And you will get pi by 3 minus 1 by 3 minus root 3. Now let's put it all together into our expression up here. So our area is this guy over here. So area is 2 times negative I1 plus I2 minus I3. So, minus I1 minus 1 by 3 plus root 3 minus pi by 3 plus I2 4 pi by 3 plus 2 root 3 minus pi 3 minus pi by 3 plus 1 by 3 plus root 3. And your final answer would be 2 times. Fractions cancel out. You're left with 4 root of 3 plus 2 pi by 3. And thus your final answer is 8 root 3 plus 4 pi by 3. And this is the end of the question. This is a very challenging paper at the end, with a lot of manipulations. So if you manage to score, let's say, above a 65 on this paper, it is quite an encouragement and you are on track to get a 7 for sure. Best of luck with your preparation.